Hi my friends, today I am going to teach you the basics theories of complex variables. So Z is any complex number so the real part of that complex number is x and the imaginary part of that complex number is y. So this is the Cartesian form of a complex number. So then the polar form it can be identified as Z equals R e to the power I theta. So here I equals square root of -1 and I squared equals -1. So we can calculate I cube as I times I to the power 2. So I times this is -1 and I cube equals -I. I to the power 500 equals I to the power squared times 250. So I to the power squared equals -1, 250. This is an even number, so 1. So Z equals R e to the power I theta. This is the polar form. Here R is radius of Z and theta is argument of Z. So we write theta as arg Z. So then we need to know about Euler's formula. So you have to remember this Euler's formula. This is very important. So e to the power I theta can be written as cos theta plus I sin theta. So similarly, e to the power minus I theta equals e to the power I times minus theta. So substitute minus theta for this equation. Cos minus theta plus I sin minus theta. So cos minus theta is cos theta. So we know that sin minus theta equals minus sin theta. So substitute here minus sin theta. So minus I times sin theta. So e to the power I theta equals cos theta plus I sin theta. So e to the power minus I theta equals cos theta minus I sin theta. I take this as 1 and this as 2. So 1 plus 2 implies that e to the power I theta plus e to the power minus I theta equals. So these two terms cancels out and we get 2 cos theta. And here cos theta equals e to the power I theta plus e to the power minus I theta over 2. This is our first verified formula. So similarly 1 minus 2. So e to the power I theta minus e to the power minus I theta equals. So these two terms cancels out and 2I sin theta. So we get sin theta equals this is the formula for sin theta using e to the power I theta and minus I theta. So you have to remember these formulas for the calculations. So then Newton's theorem So this theorem, if any power of cos theta plus I sin theta, so n comes near to theta. So cos n theta plus I sin n theta. So you have to remember this also. So sin x equals e to the power ix minus e to the power minus ix over 2y. So x is a real number. So similarly, when z is any complex number, we can write sin z as e to the power iz minus e to the power minus iz over 2i. So xy, if xy are complex numbers, so the conjugate of x plus y bar equals x bar plus y bar, and x minus y bar equals x bar minus y bar. Here x and y are complex, so you have to remember if x and y are complex numbers. Okay, and similarly xy bar equals x bar y bar, and x bar divided by y bar equals x bar divided by y bar. So this whole term bar equals bar of x divided by bar of y. So here y is not equal to 0, so y bar is not equal to 0. So we know that z is any complex number is equal to x plus iy. So the bar of z equals to x plus iy whole term bar. So we write this as x plus x minus iy. So if z is any complex number with x plus iy, so we can write the bar of z equals x minus iy. So here x and y are real numbers. So x and y are real numbers and z is any complex number. Okay, I think now you can understand. Then the modulus of z equals to, so z is this, and the modulus of z equals to square root of a square plus y square. So is square root of real z and im z. Okay. So you have to remember these things. So another formula Z bar equals modulus square root square of modulus of Z. So let's prove it. So Z equals x plus iy. Z bar equals x minus iy. So modulus of Z equals square root of x square plus y square. So Z bar x plus iy times x minus iy. So we know that here plus and here minus. So this can be written as s squared minus iy squared. So s squared minus I squared y squared. So I equals square root of minus 1 and I squared equals minus 1. So here minus 1. Minus times minus is plus s squared plus y squared. So we can write this as s squared plus the square of square root s squared plus y squared. So you can see that modulus of Z equals s squared plus y squared. So here square root s squared plus y squared. Here this is modulus of Z, and finally we get this equals square of modulus of Z. So here, so proof is completed. So modulus of Z equals, we know that square root of s squared plus y squared. So modulus of Z bar equals so this can be written as like this. So take the square of real part and imaginary part separately. So square root of s squared plus minus y squared. So s squared plus y squared. So Z bar, the modulus of Z bar equals modulus of Z, and that is another formula. So you have to have to remember these things. So I take this as 1 and this as 2. 1 plus 2 implies z plus z bar equals 2x, x equals z plus z bar over 2. So we know that the real part of z is x. So finally we get real z equals z plus z bar over 2. So similarly, one minus two z minus z bar equals 2iy. So y equals z minus z bar over 2i. So this is imaginary z equals z minus z bar over 2i. E to the power I theta, we know that e to the power I theta equals cos theta plus I sin theta. So the bar of e to the power I theta equals cos theta plus I sin theta, the bar of whole term. So we know that when we take the bar of any complex number, we change this sign. So cos theta minus I sin theta. So we know that e to the power minus I theta equals cos theta minus I sin theta. So the bar of e to the power I theta equals e to the power minus I theta. So then properties of modulus. So x is any complex number, modulus of x equals 0 implies that x equals 0. Then so if x and y are complex numbers, the modulus of x the modulus of xy equals modulus of x times modulus of y, where xy whole xy are complex. Similarly, x over y modulus of x over modulus of y. So here x, y are complex numbers. Similar for all. Another thing, the modulus of x plus y for xy in complex plane, complex numbers. So this is triangle inequality. So you have to remember this also. Then we move to a new section. Function of a complex variable. So let Z be any complex variable, so we can write it as the function of Z is Fz. So we can write this Fz as u plus iv. So let take Fz equals Z. So Z equals x plus iy. So this is u and this is v. So u xy equals x and v xy equals y. Fz equals Z square. So take Z equals x plus iy. Let we can expand this So here a squared plus I times 2xy plus I squared y squared. So I squared equals minus 1. So a squared minus y squared plus I times 2xy. So this is uxy and this is vxy. Fz equals z. So we can write z in Cartesian form, and also we can write z dash in polar form. So this is my z. Using Euler's theorem, we can write this as cos theta plus I sin theta. So we can expand like this: r cos theta plus I r sin theta. So this is my u r theta and this is my v r theta. So this can be written as Fz equals u plus I v. So can you do this? So cos z e to the power iz plus e to the power minus iz over 2. So let z equals x plus iy. So if z equals e to the power I times so e to the power I times substitute x plus iy for z, we get this. So we can write this as e to the power so I times x. So here, so we know that e to the power x plus iy equals e to the power x times e to the power iy. So here e to the power ix. Then here I squared is minus 1, here minus 1, plus e to the power minus ix times minus I squared y. So I squared equals okay, I squared equals minus 1, minus times minus 1 equals 1, so y. over 2. So we can expand this e to the power ix and e to the power minus ix. So e to the power y minus y times cos x plus I sin x. So taking cos terms out, cos x times, here e to the power y plus e to the power minus y over 2 plus taking I sin x terms out, you get as this. So take minus sign out, so we know that cos x cos y. So, cos y equals e to the y plus e to the power minus y over 2 and sin y equals e to the power y minus e to the power minus y over 2. So cos x, this is cos y minus I sin x. This is sin y. So u x y equals cos x cos y v x y equals minus sin x sin y. So this can be written as minus plus I times minus sin x. Okay, so now you can understand. So f z equals log z. in these problems, we take the polar form of Z. So Z equals R e to the power I theta. So Fz equals so this is a multiplication. So if this is R, we know that this is X, this is Y from the knowledge of polar coordinates. So here R equals square root of x square plus y square. So log plus. So I theta comes here. So theta equals, so tan theta y over x, theta equals tan inverse y over x. So u x y equals log x square plus y square, and v x y equals theta times log e. So we want to replace theta by this term, tan inverse y over x times log e. So how to prove this inequality? Think first. First, let take Z equals x plus iy. So we know that any square is greater than or equal to 0. So take modulus of x minus modulus of y square greater than or equal to 0. So expand this. So then So we know that modulus of x equals x and modulus of y equals y. So this can be written as s squared plus y squared. Sorry. So we add s squared y squared for both right hand and left hand side. Two times s squared plus y squared so we know modulus of x equals x and modulus of y equals y. So 2 times s squared plus y squared. Here square of x plus modulus of x plus modulus of y. So 2 times this is sorry. So then take square root of both sides, we get root 2 times so this is modulus of z and x equals real z and y equals imaginary z. So real z plus so finally we can get this answer. Next problem. So how to prove this formula? So we know that first of all, if this is R, so R equals square root of this. So we need this for proof to get this result. Okay. So let 1 plus I equals R1 e to the power I theta 1. So I can written R1 as, so x is 1 and y is 1. So root 2. So theta 1 equals tan inverse 1/1 tan inverse 1. So 5/4. Similarly, let's take Z2 equals 1 minus I equals R2 e to the power I theta 2. R2 equals 1 is square root of 1 square plus minus 1 square. So this is root 2. So theta 2 is tan inverse minus 1/1. This is minus 1. So minus tan inverse 1 minus 5/4. So 1 plus I to the power n equals root 2 e to the power I 5/4 to the power n. 1 minus I to the power n equals root 2 e to the power minus I 5/4 to the power n. Take this as 1 and this as 2. 1 plus 2. So 1 plus I n plus 1 minus I n equals root 2 e to the power I 5/4 . So n comes here. So I take root 2 to the power n out. So root 2 to the power n and e to the power I n 5/4 plus e to the power minus I n 5/4. Then I multiplied these 2 and divided by 2. So this is cos n 5/4 and this is root 2 equals 2 to the power half. So 2 to the power half times n. So we can write this as this. So root 2 to the power So we get 2 to the power, so NO2 plus 1 times cos N5 over 4. So this is the end of the basic theories of complex variables. So from next video I will teach you continuity and differentiability and complex plane. So you have to think this, what is continuity, differentiability, and how can we sketch a region in complex plane. I will explain in next video. So please subscribe my channel and click the bell icon and like these videos. So if you have any problems, let me know in comments. So thank you for watching me. Stay safe. Goodbye.